Greetings! Today we'll be taking a closer look at a low-cost Chinese-made switching power supply. The power supply in question is the NANKADF programmable DC power supply. This is the 30 volt and 5 amp version, making it suitable for a wide range of applications from hobbyist electronics to small-scale production work. Switching power supplies, such as this one, unlike linear power supplies, use high-frequency switching to regulate the output voltage and current. This allows them to be smaller, lighter, and more efficient than their linear counterparts. This one is quite lightweight. It's very mobile and small as well. I can easily hold it with one hand. It's just very, very small indeed. However, it can also introduce more noise and ripple into the output signal being a switching power supply, and that can be a concern for some applications. That's why we'll be putting this power supply through its paces today, testing its accuracy, stability, noise level, and other important features that you should consider when choosing a power supply for your projects. So, what are some key elements of this power supply that we'll be looking at? First and foremost, we'll be examining the voltage and current accuracy of the power supply. We all know that having an accurate and stable output voltage and current is critical when you're working with super sensitive electronics, not really including this fan, but there's lots of different electronics that would require high precision and accurate voltages. We'll also be checking how well the power supply performs at this. Next, we'll also be looking at the adjustable output feature. A power supply that allows users to adjust the output voltage and current to a precise value is essential for an adjustable bench power supply. This feature allows users to match the voltage and current requirements of their device or circuit, ensuring optimal performance and safety. Protection features are also critical when it comes to power supplies. A good power supply should include over voltage, over current, and short circuit protection to prevent damage to the circuit or device being powered. We'll test how well this power supply protects against these type of incidents. The noise and ripple of specifically a switching power supply can also be a concern for some applications. A power supply with low noise and ripple ensures that the output voltage is stable and free from unwanted fluctuations or interference. We'll be testing the noise and ripple of this power supply as well. Of course, a clear and easy to read display as well as intuitive controls are essential for a power supply. I'll be going over just some of the controls on this specific power supply in this video, and we'll also be examining to see how user-friendly this is specifically. Of course, also, the cost of a power supply can be a deciding factor for many users, especially those on a tight budget. We'll be evaluating the price of this power supply and whether or not it provides a good value for its cost. So first up, we'll be measuring the voltage and current accuracy, and when it comes to power supplies, this is one of the most important factors. This is particularly true if you're working with sensitive electronics and performing precise measurements. The good news is that this low-cost power supply we're reviewing today delivers decent voltage and current precision to be expected. I'm going to connect it to my more than ample 6.5-digit voltmeter, and we'll see how it performs. So first, I'm going to set it to 10 volts to see, really don't need the current quite that high, to see how close it gets. So we'll put this in auto range. And if you look at the DMM, I'll make it a little closer. Look at the DMM, it's measuring a little bit lower than the 10 volts that's on here. This is obviously the more trustworthy voltage meter. And so this meter measures just a little bit high. It's not a huge issue for anything that I'm going to be working with, but if you're looking for something that needs more than, say, 3% accuracy or something of that nature, then really this isn't the supply for you. It also can't, as far as I know, reading the manual, can't be calibrated anyhow, so the accuracy is a little off, but really it's not bad. I mean, for the price point that this power supply offers, it's really, I think it's within an acceptable range. Also, one thing I do like about this display is that though it might not be accurate all the way over to these precisions of 0.01 volts, I like how it has the precision available so that you can adjust it to 1/100th of a volt or 1,000th of an amp. I think that's a really nice feature. Not very many power supplies in this price range offer this amount of precision for the money. So, I think that's a great feature. It's not extremely accurate, but it is quite precise. So the power supply that we're reviewing today offers output voltage and current up to 30 volts and 5 amps, which should be more than enough for most DIY hobbyists for projects, things like that. Unfortunately, however, this power supply only has one output. So if you need to do anything more complex or have multiple voltage rails, then you'll either need to pick up another power supply, which is what I have. I have a few different power supplies, or you can purchase a different supply that has multiple outputs, but this one just has the one output. So next we'll be looking at the protection features of the power supply. And a good power supply should include over voltage, over current, and short circuit protection to prevent damage to the device or circuit that's being powered. The power supply we're reviewing today includes constant voltage and constant current. And if you happen to short a circuit, that's usually protected by the constant current. So this fan is a 24 volt, 210 milliamp fan. So if we're to only allow it 100 milliamps of current, well, this will put it into constant current mode. I don't know if you can see there, but right here it illuminates a little CC indicating that it's in constant current and the current protection mode. If we were to increase the current that we allow for this fan to draw, then this is going to, of course, increase the fan speed, but also since it's still, a 210 milliamp fan, it's going to draw the maximum it can, 200 milliamps, but it won't quite reach the set voltage of 24 volts. Now, if we were to allow it even more current, let's say 300 amps, well, then this is above the 210 milliamp current draw of the fan at 24 volts, and so we'll get into the CV mode, the voltage control mode of this power supply. So both of those work wonderfully. In terms of short circuit protection, well, it basically protects itself. If you were to short it for some reason, let's say you weren't paying attention and you just happen to short the leads, it just goes straight to constant max current mode, and it's able to supply 0.3 amps at very little voltage because there's very little resistance here with no problem. So there really shouldn't be too much of an issue on that front either. So a power supply with low noise and ripple ensures the output voltage is stable and free from unwanted fluctuations or interference. Noise and ripple refer to different types of unwanted signals that can be present on the output voltage. Ripple is the term used to describe the high frequency variations in the output voltage of a switching power supply. It's caused by the switching action of the power supply as it converts the input voltage into the desired voltage. The switching frequency of a switching power supply is typically in the range of tens or hundreds of kilohertz, which also means that the ripple frequency is in that range. Noise, on the other hand, refers to unwanted signals that are present on the output voltage of a power supply at frequencies higher than the ripple frequency typically. It's caused by a variety of factors, including electromagnetic interference, EMI, from other electronic devices, from ground loops, and the internal noise generated by the power supply circuitry. Noise is usually measured in units of decibels and can be present in both the low and high frequencies. The key difference between noise and ripple is their frequency range. Ripple is a high frequency signal that's caused by the switching action, while noise can be present at both high and low frequencies, and it can be caused by a variety of factors. It's important to note that both noise and ripple can have negative effects on the performance of electronic devices that are powered by the switching power supply. Excessive ripple can cause problems with sensitive electronics, while noise can interfere with the operation of high-speed circuits and communication systems commonly. Therefore, it's important to choose a power supply with low levels of both noise and ripple to ensure optimal performance of the circuits that you'll be powering. I tested the power supply first by connecting it just at 1 volt to my oscilloscope to see what signals I could measure straight from the outputs, no load, And if I do a little bit of averaging, then you can see the noise. There is a little bit of noise, and you know it's noise and not ripple because it's at about 14 megahertz. So it's much, much higher than the frequency, the switching frequency, which traditionally is in the kilohertz. So I would assume that this is some sort of megahertz, probably due to some current loops, capacitive loops, something that's going on within the circuitry itself. It probably doesn't have the best EMI performance out of most power supplies. It's pretty cheap, low end, so I wouldn't expect it to have a whole bunch of EMI shielding taken into account. So that's with basically no load. We're getting a little bit of consistent noise that's going on just on the outputs. Now if we go to connect a load, I'll do that. Okay, so here I connected an LED light bar, which has the capability of pulling more current than this supply can handle at 12 volts. So it's going to be current limited the whole way. But what I've done here is connected it, and we can turn the output power on. Obviously that's pretty bright, so I'm going to set it aside off the video so it doesn't affect too much. Looks like it's a little bit hard to see on the oscilloscope just due to the frame rate of the oscilloscope potentially messing with the image. But you can see here that there's a little bit of transient signal on the line as well. This one, however, is a little bit higher frequency. It's more like, I don't know, it's fluctuating somewhere around 29 to 32 megahertz now, so it's a little bit higher frequency than before, which leads me to believe that this effect is happening inside of the circuitry of this power supply. Also, it's worth noting that when it's drawing, I guess 55 watts or so, the power supply, it feels a little bit warm to the touch. It's not hot, and I don't expect it to get hot. I've actually used it to power this light for quite a while at some points, but yeah, it doesn't get hot, but it is quite warm. So another thing to note about this power supply. One thing I should have mentioned too is the amplitude of these oscillations. They're approximately 1 volt tall, peak to peak, or well, peak to peak is more like 2 volts. So yeah, the amplitude about 1 volt, peak to peak it's about 2 volts tall. So finally, I wanted to talk about the display and controls specifically on this power supply. So this supply features a large, bright display which shows all the relevant information. I love the display. I'm a big fan. It illuminates well. The LEDs are a nice touch. The controls are mostly easy to use except for when setting the voltage and current when the output is enabled. I found this to be not super intuitive because, well, let's say output is enabled. And if you're changing the voltage, it blinks for a little while, and I'm never sure if the blinking, has it changed yet, or only once it stops blinking has it actually changed and it's going to output those parameters. Well, it turns out that it actually changes it in real time. So as you're, scrolling through the different voltages, it is actually changing the voltage output in real time. You might have noticed that earlier when we were looking at the output of the voltage on our DMM that, yeah, it was in real time, but it took me a little bit to figure that out when I was first figuring out how to use this. Another kind of interesting feature, which I actually like, is the fact that you can change the decimal and just change these all independently. And you might think it's a little bit tedious. I thought so at first as well, but I've grown to like that feature as well because it allows you to change the voltage much quicker than if you had only one dial and you were trying to change, let's say, the 100th place on the voltage. That's going to take a long time on just a manual dial that changes the whole thing. But on this, it's quite easy and straightforward to do as well. Another thing about the UI that I like on this power supply is the output button. A lot of power supplies don't have this output button. I think it's really nice because you can set the voltage before you output it. through the leads, which is nice because maybe you have it already connected in your circuit and you don't want to output the wrong voltage. Maybe you only want to output a very specific voltage. Well, you can set the voltage ahead of time before you go to output it from the supply. And this can also prevent mistakes from happening. Maybe you set the voltage to be 12 volts last time, but you want to change it over to be 5 volts for a different device, but maybe it was still set to 10 volts and you accidentally connected the leads first and you powered the supply with too much voltage. That mistake would hopefully be minimized on this DC power supply. One other feature that I like on the front, connectivity-wise, is the USB. It works fairly well, though I have noticed when I'm plugging my phone in to charge using this USB port, it makes a loud kind of whining noise. It's a really high-pitched noise, and it makes the same high-pitched noise as when I have large loads connected, such as when I had that LED light bar connected to this power supply. It kind of makes a high-pitched, just a high-pitched noise. And it doesn't bother me that much, though it would get irritating if you had to listen to it all day, every day, I would imagine. I don't use power supplies for more than 10, 20 minutes at a time typically, so I don't mind it that much, but if you are going to be using it a lot, that is something that you'll want to think about is, if you're going to be also, using the power supply a lot and drawing high power loads, say more than 10 or 20 watts, it does make this kind of high-pitched whining noise, which I find to be quite annoying. I'd say that's my major complaint about this supply. So this power supply also features a built-in fan, which helps it cool, keep it cool during operation. In theory, the fan is it's built in there. However, whatever I've done, I've never actually had the fan activate. I've never heard or seen the fan activate at all, even while I was drawing that 50 watt or so load from the power supply, and it was warming up just here a moment ago when I had the light bar connected to it. The fan still didn't power on, which is to me a little concerning. I'm not totally sure why that is. I suppose I could pull it apart to see if it's even connected to the circuitry, though I'd be shocked if it wasn't. But yeah, I really don't know what it would take to get the fan to activate. Maybe you have to draw even more power from it. I'm not sure, but you would think it would start turning on and blowing once the unit starts getting warm, which it was warm to the touch earlier. So I'm a little bit surprised that it didn't turn on, but I guess it not turning on when it doesn't need to be on helps keep the noise down. So that might be a positive thing as well. It just depends on if the fan works at all or not. Another thing that's a little strange about the back is there's this kind of open connector. I'm not sure what this was for. Might have been in production. Maybe they had it open at one point for USB. It kind of looks the right size for USB-A, but I'm not totally sure. I also don't know why they didn't put a little plastic bit in there. It kind of bugs me. Maybe something could fall in there, or dust could be introduced through that hole. So not that there aren't plenty of holes on the power supply body, but that one just seems a little odd. Another thing to keep in mind when you receive the supply, make sure that you put it in the right voltage mode. I believe, I got this power supply about a year ago. I believe it came set to 115 volts, but make sure you check before you plug it in. I know this specific power supply is sold in many countries, so just make sure it's set to the proper voltage before you plug it in and power it on, because the manufacturer might not have preset it to be the correct voltage for your location. So I know the cost of a power supply can be a deciding factor for many users, especially those on a tight budget, such as me. The low-cost Chinese power supply we're reviewing today is an excellent value for the price, I think. It delivers all the essential features and performance that I need at a fraction of the cost of many other power supplies. I purchased mine for about $50 a year ago. Now they're listed for $62.99 on Amazon. And you can see the link in the description below to find it on Amazon. That's an Amazon affiliate link, so if you click it, that helps my channel as well. As far as the brand reputation and customer support go, this power supply is not really from a well-known brand. I'd never heard of them before. I hadn't had any interactions with their customer support either, but that's to be expected from a simple power supply off of Amazon. You shouldn't need too much technical support for this model, except for, I guess, malfunctions if you received one that was DOA or something. That all would be handled through Amazon itself, not specifically with the manufacturer anyway. So there was a manual that came with it, and the manual was fairly basic. It didn't really have too much there. There are a few kind of programs that you can go through that turn on and off the beeping, but there isn't really any, like, it says it's a programmable DC supply, but there's no like ramp features. There isn't anything, I guess, super programmable about it other than that it's able to adjust its voltage and current like you would expect a constant current or constant voltage supply to do. In terms of the noise level, I kind of covered this already, but there really isn't any noise from the power supply, which is nice. It's very low noise until you start pulling high powers or high current from it. Once you start pulling, more than an amp, something in that range, it starts kind of having this high-pitched noise that comes from inside, probably from the circuit somewhere. So all in all, this power supply offers a lot of features for its price point. It's an adjustable bench power supply that can output up to 30 volts and 5 amps, making it suitable for a wide range of electronic products and testing applications. With its single output channel, its protection features, it's reasonably low noise and ripple, and its clear display and controls. It's a versatile and reliable tool that can help you achieve accurate and stable power output. While it may not have all the bells and whistles of more expensive power supplies, I think its affordability and its portability, kind of lightweight features make it a great choice for anyone that's on a budget. And it's I think, all in all, a pretty solid power supply. So I'm definitely going to keep it. It's going to be on my bench, and I use it for testing regularly. So, I think it's probably one of the best options out there. I've tried a few of these kind of cheaper, low-end power supplies, and this one kind of has the least oddities out of any of the ones I've tried. So I recommend it. Thanks for watching. Bye.